Hello everyone, I am Monesh. I will be showing the final demonstration of our project. First, let me start the server. So, after starting the server, this is the web page that is loaded. This web page has three main features. First is upload question paper. Mm, This is the place where the faculty will upload the question paper with its paper ID and the release time after which the question paper will be released and the original question paper. First, let us upload a question paper. Let us enter paper 1. Release time will be few minutes from now on, and let us upload a sample question paper. When the faculty clicks encrypt and upload, this question paper will be stored in Pinata Cloud, and the IPFS, those details will be stored in blockchain. See, this is the IPFS hash. The same IPFS hash will be given by the Pinata Cloud. See, this is the paper we have loaded, and this is the CID. You can see here the IPFS hash is same, and this paper is not stored in its original format. That is, the paper is encrypted so that no one can know the details even if they somehow come to know the IPFS hash. This transaction will be stored in the blockchain contracts. Question paper storage is the contracts we are using in this implementation. This is the transaction hash that is shown. See, this is the transaction hash. In this transaction, we can see that the paper ID and the IPFS hash, release time, and the AES key that is used for decryption of the question paper are stored, and it also stored what kind of event this is. After the question paper is uploaded, one should to decrypt the question paper, one should connect their MetaMask wallet, and only authorized users can connect their MetaMask wallet. Uh, Let us connect this MetaMask wallet. You see, this is authorized wallet because this is the account we are using for uploading the question paper. In this implementation, we are using the first address to upload question paper. That is, this is the admin's account. If we try to connect some other accounts, we can connect and we can't get the question paper. This account is not authorized, so only authorized users can connect to the web page and they can download the question paper. Only the admin has the access to add authorized users. Here the admin is the first account, and that is the faculty. For example, if the admin wishes to add this account as an authorized user, then he should enter that wallet ID, the authorized users. Okay. Sorry, the only contract owner can add users. That is, we are in some other account. First, we should change it to the admin's account. Imported account one is the admin's account. If we add now, see the new authorized user is added now. If we try to add that account to our front end, now it will be authorized. The imported account 2 is this account. If we connect now, see this user is authorized now, but before it is not authorized. After authorization, they should enter the paper ID. Paper ID is paper on. So if they enter the paper ID, it will fetch the question paper. That is, if the timestamp has been that is, if the question is released, then the user will receive the question paper. See, the question paper has been downloaded, and each transaction will be stored in the blockchain. This is the final transaction, that is record access. In this record access, it will show who downloaded the question paper. As you can see here, the wallet address is shown. For example, if we upload some other question paper, If we try to access before the timestamp, we cannot download the question paper. So our question paper security system ensures both the timely access and the authorization. Only authorized users can download the question paper. Thank you.
Hello everyone, my name is Nandan. Today I'm going to explain the front-end part of our project, blockchain-based question paper security system. Here, this is the code which explains the design and everything, and every icons we have shared on our website. And this is the input text to enter paper ID or date, release time, and this is the code we have used to display the front-end part. And this is the buttons or cursor used can access by the user to improve the user specifications. And button over is this is the button over background color to show the front end part of the user. And this is the decrypt button, this is also decrypt button. And this is the wallet button to improvise the different colors so users can understand easily, and it makes a interactive one. And admin results, this is the admin results we have used, so that we'll be using it. And for upload session we have used this code to so the user can enhance understand easily. And for decrypt section we have used this code. And for admin session we have used this one. Then utility h2, this is the code. For metamask front end part we have used this one. For flash caseway to verify authentication we have used this. The user can upload question paper, so we have arranged the code to make it as interactive one and understandable. We have used this code. Then decrypt question paper part. And admin user, here the admin can add another user or give role to another user or a faculty. Like HOD can give access to a faculty for decrypting the question paper. This will send the address to backend part, and this is the code end part of the code. Now I will explain how this works. CD. Now we will connect backend, then we will go to front end part. The backend is connected now. Now we will go to front end part. Now the web browser will be accessing. We will open a new window and we put localhost last 8000 internet. This is the front end part we have used, and this is the display image display part. Here the user can give a paper ID or an to, and here the user can set the release timing. The user can choose the file, then encrypt and upload it. Then upload is will be shown here. Then for decrypting the question paper, the user needs to connect to MetaMask wallet. If admin only if the admin is given role to the user. Like HOD gives access to the faculty. Faculty can decrypt the key over all. No one can access. Then this is the admin part we have used in the code. Like the suppose if a new person is trying to decrypt the if you don't have access, the HOD or an admin can get his wallet address and give his role like an add authorized user. Then the role will be accessed. I'll add so the user can decrypt the question paper. These are the part we have used in our front end part. Thank you.
Hello everyone, I am Ram Vignesh. I am going to talk about the backend of the project. This is the Ganachi part. Here we have the Ganachi part. This is the link which Ganachi links with MetaMask, and we need to include that in our backend part. Here we have the this code. We have the Pinata API configuration. Pinata is used for storing the question papers, and we are saving the hash keys in that Pinata API. It's a free API. Anyone can use that. We need to give the key name, and we need to give admin access. I have already created an admin key. This is the key I have created and used it. This is the admin key, and we are going to create a new key. We can give restrictions to only read the files, groups, or gateways, anything, and we need to click continue. This is the API key information. We need to copy this API information. It will only show one time. We need to save that in somewhere else in textpad or notepad. We cannot see it again. We can only see the API key. We need to copy this API secret key and JWT secret access token. We need to put that in our backend part code, Pinata JWT and URL for Pinata. We need to load the contract details in our program. This is the code for that. This contact address is taken from the truffle and we need to give it there, which is linked with Ganachi, and it shows transactions. I haven't created in transactions. It shows transactions, contracts, anything with this key. And this is the Flask setup. It always creates a Flask, like in the terminal. When we create the Python app, it always creates a link. When we direct to that link, we can see the website. This is the route for uploading file API. When we click upload in that file, we need to enter the title, and we need to put the release time, and we need to choose the files, and we can encrypt. Yeah, the now the file is encrypted. Using this AES encryption, the file is encrypted and it will load in the Pinata API. It will load in the Pinata API. This is the code for that. Here I have included the Pinata API in different accounts. This is the app route for decrypt paper. When we click decrypt, it will refer the hash value from the Pinata API, and it decrypts when the release time is used. This is the code for add user. Here admin, we have MetaMask. Here we can only admin can add the. Here I have imported one account. By clicking that account, I can create another account. I can add another account as a user under my admin. This is the code for that. It will this code will check whether the user who is adding the another user is authorized or not using backend and front end. This will check the authorization using this Pinata API only. We are saving the files and using this API key we are accessing and saving the hash keys inside that file. That's all about it. Thank you.
Good day to everyone. My name is Pratibha, and today I'll be presenting you my contribution to the blockchain based solution for secure storage and managing the question papers. This system is built using Ethereum smart contract written in Solidity, deployed locally using Truffle and Ganache. Project objective. The goal of this project is to ensure that the question paper are stored secured and accessed only at the right time and manage transparency. Traditional systems are prone to leak and unauthorized access. By blockchain, we can enforce strict access control, maintaining audit logs, and decentralize the storage. Let me first explain the tools I use. Solidity, the programming language used to write small contracts. Truffle, a development framework for compiling, deploying, and testing smart contracts. Ganache, a local blockchain simulator used for testing. IPFS for decentralized storage. AES for encryption. Ethereum.js, a JavaScript library used to interact with Ethereum, including a dependency. First, I would like to say about the truffle configuration. So, this is the truffle code. This defines how truffle connects to the blockchain and which compiles the version to use. The deployment network connects to the Ganache on the localhost. The compiling version is set to 0.8.19 to support modern solidity feature like safety, math, and custom errors. Next is migration contract. It is saved as migration.sol. The contraction is used by Truffle to track which contract has been deployed. It ensures the contract are deployed in a correct order and only once. Key features: the owner, the address that deploy the contract, the restrictor. The restrictor modifies ensures only the owner can mark the migration as complete. Set complete updates the migration. The question paper storage.sol. This is the main smart contract. This is the core of the system. It defines how question paper are uploaded, stored, and accessed. Each question paper includes an IPFS hash for decentralized storage, a release time to contract access, an AES key for decryption, and the uploaded address. The flag to confirm the paper exists. The uploaded function. The only the contract owners can upload papers. It checks that the paper ID is unique and release time is further in the future. Once updated, it emits a paper uploaded event. Access function. It is the current time in past that release time. It emits paper download. If not, it emits access denied. So get detail function returns the IPFS add hash and AES key only if the paper is released, prevent earlier access and uh, protect confidentials. Yeah, the paper upload is triggered when the paper is uploaded. The paper downloaded is triggered when the paper is accessed. Access failed is triggered when the access is attempted earlier. These events are stored in the blockchain and can be monitored off chain for the audit process. Deployment dependency, that is package log JSON and package.json. The install ethereum.json, a light version light version of JavaScript library for interacting with Ethereum. It connects the front end to the smart contract and perform the blockchain operation like reading data, sending transaction. In the package log JSON, we see resolvent dependency includes Draftly and EMA normalization for ENS, Nobles or Curve for cryptological operations, AES.js for AES encryption, and Lite for TypeScript support, and VS for WebSocket. These packages ensure secure encryption, reliable blockchain communication, and compatibility with modern JavaScript. An unauthorized access release control is time based. Lack of transparency logging prevents by the blockchain events. Centralized storage risk and decentralized storage is by IPFS. For confidential of content by AES encryption, front end integration by Ethereum JS. Summary of my contribution: I wrote the smart contraction in Solidity to manage question paper security. I contributed Tuffle to compile and deploy the contraction using Ganache. I implemented access control using timestamp and ownership. I used event log to update an access attempt. I managed the dependency using package.json and package.log.json, ensuring security in cryptographical support, front-end integration. Thank you for listening. I'm happy to walk through the code or